Fast cycling is the use of functional electrical stimulations in repetitive cycling exercise. It's used mainly for spinal cord injury in post-stroke patients for both physical and psychological benefits. The aim of the work is to determine the muscular activations and the fatigue onset through the amplitude and frequencies analysis. The acquisition consists in the recording of the activities of the rectus femoris and hamstrings during cycling with increased resistance.
The signal preprocessing consists of these steps. In order to obtain a more regular signal, we want to maintain a cadence around the desired one, which is 50 revolutions per minute. That's why we deleted the first and last 10 cycles. Identifying muscle activation onset requires a defined envelope. Initial exercise cycles with unusually high EMG peaks were excluded, considering them as movement artifacts due to the expected smaller initial amplitude.
The crank angle corresponding to the onset of muscular activity needs to be determined to obtain a correct timing in the stimulation of the muscles involved in cycling. Literature suggests a faster single threshold method compared to a double threshold approach. In fatigue conditions, a different muscle activation pattern is observed, resulting in an increased range of crank angles. Is this result significant? The p-value doesn't support a significant increase, likely due to the dataset, which is too small to obtain statistical evidence. It is important to specify that the kinematic changes is mainly due to the increase of the pedal's resistance during the exercise.
From the literature, we found that the amplitude of the EMG increases with fatigue. To verify that, we compute two indexes, the mean absolute value and the root mean square. Our results show an accordance with this theory, but this could be affected by the increase of pedal's resistance during the exercise. We then try to calculate these indexes in a period when force is constant. We did a joint analysis, forces, amplitude, computing the root mean square for the first 60 cycles and for the last ones in a situation of constant force. The slope of the interpolation line is greater in the last part of the exercise, and this can be due to fatigue. More interesting results about the fatigue onset are provided by the frequency analysis. The EMG is not stationary, so we work on a single cycle. We evaluate the median frequency obtained through periodogram, average over 10 cycles with 50% of overlap, in order to have the possibility to use these devices in online applications.
According to the literature, a negative slope of the regression line suggests the presence of muscle fatigue. Below table results using rectangular or arming window are along with referenced articles. This analysis indicates that the rectus femoris is more related to fatigue, while the biceps femoris mainly contributes to kinematics and stability. To conclude the fatigue investigation, two indexes were employed. The fatigue process manager do not only characterize the fatigue progression, but it can also determine the fatigue onset by using a proper threshold. The Dimitrov fatigue index using the fifth order spectral moment is an optimal choice to detect and track muscle fatigue, in particular during functional electrical stimulation, with respect to conventional indicators such as root mean square and median frequency. As future developments, implementing the TK energy operator can enhance the identification of muscular activity ranges. Then, performing an exercise with constant resistance and kinematics will facilitate joint analysis. And lastly, the Kim index can offer the essential upgrades for an embedded device.